Okay, hopefully I didn't screw up the recording. Okay, this is what's actually going to happen here. What I really have, see, clear, I have these new factors, this factor and this factor. These are my new coordinate systems, just like in PCA. These points, 2 and 5, are in space along this F1 and F2, okay? This is my original dimensions. These two lines represent, the thick black line represents my new factors. Now you're going to notice these guys seem to be closely related to this factor because they're closer in distance. And if you remember from before, which I can't do that here, let's go back. You remember from before I had two factors that were 9.69 and 0.971, right? I have 0.8, on the other one. So we have 1, 4, and 3, right? Which were some of the other ones we were talking about. 1, 4, and 3 are loaded on this first dimension. 2 and 5 loaded on the second dimension. Okay? We weren't too sure, I think, about, what was it, 5? Where it loaded? Well, what's funny is when I do the rotation, and we can do this graphical rotation, which is what's called a cosine rotation, which you don't have to do. But if I use the Varimax rotation here, if I use the Varimax rotation, look what happens to the numbers. This, remember, this was our first set of loadings, not 0.951. It's pretty much the same as the 0.969, isn't it? But now, this 0.51 and 0.807 change. Look at how drastic it changed those numbers. It created a separation, a complete separation. The one that we had a problem with was this one, 0.704, 0.667, right? Look what happened to the rotation over here when we did the rotation. By using the rotations, it will make loadings appear more evident without losing any information at all. The rotations are merely just shifting things to the left and to the right in this unit circle, just going right around, and I never lose any information. Just because those numbers changed does not mean I'm losing any information. In fact, what it's doing is it's helping me interpret it better because it literally rotates around this origin, around the center origin. Yes? Yeah, that's a great that's a great question. The answer is generally you're not going to get a nice clean solution without rotation. If it happens, great, you don't need it. But most of the time, like 90%, especially for homework and tests, you will need to do a rotation. Okay? Make sense? Cool. Yeah.
Is there a time when you would want to look at the non-rotated values prior to seeing the?
You're always going to look at the non-rotated values first, okay? Because you want to see what they are non-rotated. A lot of academians will just ignore it right away and jump into the rotated values because in general, like I just said, most of the time you're going to need to do a rotation. I like going through the steps. I want to see what it is without the rotation. I'm not losing any information by doing it. But what it does is it tells me how good the solution is without doing anything else, okay? Anytime if you don't have to do a rotation, it means those items are so highly related to each other that it becomes very evident. And I like to know why, that's what I do. So here, I have the Varimax. Now this is a totally different example, okay? But in this case, I did a Varimax loading. I've got 0.87, 0.86, 0.82, 0.85 with a Varimax loading. That same set of data under an oblique, which in this case was ortho oblique, which actually was the Promax, you end up with 0.90, 0.96, 0.97, 0.95 on the 2 and then the 1. It actually made the loadings better while preserving the correlation. What do I mean by preserving? What I mean by preserving, remember I did this where you keep a 90-degree angle between the two axes? Notice here, There is no 90-degree between these two axes. It is literally just creating two new axes in space, or axi, depending on what the English word for multiple axes is, and giving me the points around them. Usually, the oblique will give you better rotations, will give you better loadings, because it's literally trying to give you the highest set of numbers. That's what it does. And it preserves the correlation. What do you mean preserve the correlation? Look at those two axes. I said that orthogonal was like this, right? Perpendicular. Are those perpendicular? No. They kind of go in the same direction. And if they go in the same direction, there is a correlation between them that I can measure. Does that make sense? And I'm just creating a new coordinate system based on these two axes, or axon. Now, yeah.
So for the negative values, like obviously correlating to the plane, that makes sense. But like, if you ever have like a negative 0.99
Yeah.
or something.
Yeah, it go in the opposite direction, absolutely.
And
That's exactly how you interpret it, 100%. So in confirmatory factor analysis, rather than trying to determine the number of factors, we basically know the data, but we will use confirmatory analysis because we know the structure. I know I should have 3 factors, or 2 factors, or 5 factors. It specifies, it's more specific on figuring out what loads onto what factors. This is usually done when you know ahead of time. I have 9 items, 3 items belong here, 3 items belong here, and 3 items belong here. It should line up. If it doesn't, it means something was wrong with my, let's say, survey or with the data, okay? That's how they use it. They do a confirmatory factor analysis to make sure that if I'm asking 12 questions and there's 3 factors, these 4 should have loaded together. Do they? Yes, we're good. These 4 should load together. Do they? Yes, we're good. These 4 should load together. Do they? No. Oh boy, I got a problem. Because they should have loaded together according to my research and according to papers or whatever it is, and they didn't. Think about this. You're trying to ask for satisfaction, and you say, how satisfied were you with the product? How satisfied were you with your purchase? How satisfied were you with the store? How satisfied were you with your service? And it does not load on satisfaction. Those items can no longer be used to tell you about satisfaction. Does that make sense? That's why we do this for that particular case. So in a 2-factor analysis, same chart for CFA, only those items are forced to load on those factors. We do not allow the factors to create any other equations, meaning our numbers are going to be slightly different. Don't need this because you're not doing that. All right, now we're going to do an example. Okay, we're going to run through an example both in R as well as on the PowerPoint. I'm going to try and do this here. I'll find this. If you go into your R code and you go to factor analysis, we're going to load up that data set. Okay. Before I start, I'm going to type this BFI, question mark BFI. I'm going to see what happens. You might want to install a couple of packages too. We need to install Psych and we need to install GPA rotation. Okay? Psych and GPA rotation. Now, you see up here in line 3, I've typed question mark BFI. It's only in a comment for you, but I'm asking you to type it. Are you kidding?
Case sensitive.
No, hold on a second. I'm going to bet you I'm missing a package somewhere. Let me see something. Hold on a second. Yeah, it should be in the Psych package. Oh, you know what? I think I just installed it. I don't think I loaded the library. Let me see. There we go. Yeah, I didn't load the Psych package. It's in the Psych package. So when I do question mark anything, question mark anything. That will give me the help. That's all it does. Gives me help, right? So now on the bottom, you see how it says BFI Psych is a data set, 25 personality items representing 5 factors. Now, ideally, I would use confirmatory factor analysis for this, but we're not going to. Why would I use confirmatory? Confirmatory because I know there are 5 factors, okay? That's why I would use confirmatory. But I'm going to use exploratory. You okay? You missing something? Good?
I'm looking for BFI.
Load the psych package first. Make sure you put the library. Just type BFI. Okay? I haven't done that yet, but I was about to. If you type BFI by itself, you see the data set. Okay? You see that down below? Doesn't give you everything. It gives you most of what you need. Notice at the bottom, what does it say that I highlighted? Huh?
It doesn't show you all
Doesn't show you all the rows. Okay? Doesn't show you all the rows. And the reason it doesn't show you all the rows is because it doesn't have enough room. It doesn't want to waste space. So it's only showing you first 100 or whatever the number is. Okay? It's 2,800. It's actually showing you 35 rows. Okay? Now, look at line 12. What does line 12 do? If BFI is the data set, what does complete cases do? I've done this with some of you, so you should know. Well, it removes items, any rows with the NA. When I put it inside of these brackets in the row section, which is right to the left of the comma, what is that going to do? What is this going to do? So if I run complete cases, it actually tells me true and false. It tells me which rows are complete. There's no NAs. Does everybody see that? Is everybody good with that? Is there anybody not good with that? Going once? Going twice? Going 3 times? I can't hear. Say again? Oh, wait. Anything that has an NA will return a false. Anything that is complete will return a true. You see how I'm putting this inside of the brackets here? To the left of the comma? The left of the comma is the rows, right? The right of the comma is the columns. Since there's nothing to the right of the comma, all columns. To the left of the comma, only those selected rows that are true. BFI is the data set. So I'm saying, give me data from the BFI data set whose rows are complete, and then give me all the columns. Does that make sense? Look again here. Let's see. Here we go. This is the data set BFI. What rows would you like? Because I'm using the brackets here. I want all the complete cases of BFI. Give me, the trues and falses. Give me only those that are true. And then, since there's nothing after the comma, give me all the columns. Okay? When you run this, I'm putting this into a new data set called BFI data. I will run this. And now look what I've got. How many observations am I pointing to here? 2,236. How many observations were there in the data set? You got to read in the help here. 2,800. So what did I lose? I lost about 500 and so observations, 564 observations, right? Would that be a concern?
Yeah, that's a concern.
That might be a concern that I have a lot of NAs. But in this case, I can't do anything about it because I'm going to need some complete observations in order to do my factor analysis. Does that make sense? You look at the data, I identify, hey, if I get rid of all the NAs, that's a lot of NAs. Could be important. You're talking 500 rows out of 2,800. That's almost 20%. That could be an issue. But we will proceed anyway. Okay? Make sense? All right. Now, the first step we're going to do, now that I've got my data, the first step that we're going to do is this. So here's the data. Oops. Zoom share. See clear. I talk about the data. It's got 25 personality self-report items from the interpersonality item pool. Great, fantastic. 28 observations. However, removing observations with NA results in over 2,236 observations. And I talk about the data. The variables are categorized as agreeableness, A, conscientiousness, C, extroversion, neuroticism, and openness. What does that mean? If you look at the data set here, BFI data, you see these A1, A2, A3, A4, A5. 5 items that measure agreeableness. C1, C2, C3, C4, C5. 5 questions that refer to conscientiousness, etc., etc., etc. And there's E's, N's, O's, gender, education, and age. Good with that? Now, if I'm going to do a factor analysis, listen to this carefully. If I'm going to do a factor analysis, which variables do I need from this data set to do the factor analysis?
All the continuous variables, so all the question answer surveys.
What about gender, age, and education? Huh?
Yeah, they're already as a dump data.
They're ordinal data, so you can't do that. You can't.
It actually doesn't matter that they're ordinal. Think conceptually. Don't worry about the statistics or the type of data for now, because they're all numeric, right? They're all numeric.
What do we want to see if gender has an impact?
On what?
On the factors.
On the factors. So if you want to see if gender has an impact on the factors, right? Do you want to load it into a factor, or do you want to keep it separate? Loading it in is, what do you get? Why separate? Because then I can analyze the factor against the gender independently. Whereas these items, A, they're all kind of connected because they're survey items. B, C, E, O, and N. Those are all items that I want to see how they're connected to because there's too many of them for me to deal with. But the age, gender, and education might be the items that I want to see how they relate to these overall factors. You see that? You'll get you might have an example of another data set in which you're analyzing a sport team or a group of sports players, okay? Do that. And they have different skill levels. And it says, you know, they're from this team and they're left-handed and they're this. But if I'm trying to develop a factor analysis, I only want to create factors on those items that are somewhat like each other so that I can see how they separate into factors and skill items. Yes, we're dealing with exploratory because I'm saying I'm only using these 25 variables, but I have no idea how many factors I'm going to need. Now we're cheating because we kind of know, right? But we're going to pretend we have no clue, okay? By the way, what did I do on this slide? What did I do in this slide? What did I do about the data in this slide? I described everything that I needed to know. Did I have any major concerns? I could have put some as a concern there in that third line or third paragraph, right? Notice it's kind of like the homework and stuff. Here are my problems and so forth. All right, first thing I need to do is I need to develop a correlation matrix. Do people do this? No. Should they? Yes. There's so many things I could tell you that people do on papers, academic papers, that they should do and they never do. I'm talking conferences and journal papers, not just like student papers. We need to basically test to make sure that there is correlation, that the correlation matrix means something. If every single item was not correlated with each other, every item was not correlated with each other, could you do a factor analysis? You could, but would it have any meaning? No, because the idea of the factor analysis is that the items would load and they would be coupled together. They would coalesce together. So the first test I have to do is what's called a Bartlett test. The null hypothesis is that the correlations are 0. The alternative hypothesis is that the correlations are not 0. So in your code, we do that here. I take BFI data. Oh boy, look what I did. I removed 26, 27, and 28. Should I do that? Yes. Why? Gender, education, and age. Gender, education, and age. I'm removing those columns because I don't need them. I'm doing a correlation analysis on only those items upon which I'm going to do my factor analysis. So I create my correlation matrix, and now I'm going to do this test called the core test Bartlett, or the Bartlett correlation test. Pass in the core mat, which is the matrix, and n is the number of rows. Here is a new function for you, because I don't think we did this. N row. N row will give you the number of rows in a data frame or matrix. I'm sorry, only in a data frame, not a matrix. Okay? So here, n row, I'm going to run this by itself. And it tells me there's 2,236. I'm going to pass that into the n. Wait, Professor, how do I know how core Bartlett works? Well, that's a great question. So I'm going to do Bartlett test, which is a little bit different. I'll do this. Core test Bartlett. There you go. Look what it says. Here's my help for the core test Bartlett. What's the first parameter? R. What does it say R is? In the help, what does it say R is? It's a correlation matrix, right? And N is going to be the sample size. It's not specified, 100 is assumed. I have no idea why you would assume anything on it, but N is the sample size, total number of observations. So now what we do is we run the core Bartlett test. And there we go. I'm only concerned with this p-value here. What is my rule for hypothesis tests? If the p-value is what? If the p-value is 0.05 or something else? Less than 0.05, what do we do? Huh? Yeah, if the p-value, again, is less than 0.05, we reject the null hypothesis. Else, what do we do? Ow! That hurt. What do? We do not reject H0. Now, why did I go crazy when you said accept? I don't even know who said it. Don't want to know. All right? Why did I go crazy when you said accept or when accept was set? Why is that not valid? Because we are not proving, huh? It does not prove it to be true. That's correct. It only means that we have a probability of rejection or not rejecting H0. That's it. We're not accepting any premise whatsoever. Okay? So in this case, what was my null hypothesis? That the correlation matrix was 0, where there's no correlations. Do I reject or not reject the null hypothesis? We reject the null hypothesis, and therefore I have evidence to support what? That the correlation matrix is not 0, that there are correlations. So now I can proceed and do my factor analysis. Okay? Cool. Right here. Yep. It's too small. Okay, so now that I got that, here's our example. There are 3 different packages to run correlation, to run factor analysis. FA, FactAnal, and CFA. CFA is specifically for confirmatory factor analysis. You can do exploratory factor analysis with it. I choose not to because it's going to confuse the living hell out of you, but there's a way to do it. Okay? We're not doing it. We're only going to be using FactAnal here. Now, FactAnal is pretty easy because all I got to do is run FactAnal. Whoops. All I do is run FactAnal, and I pass in the data and tell it the number of factors that I want. That's it. FactAnal, the data, and the number of factors that I want. Now, you asked before, well, how do I choose the number of factors? Well, I kind of want to choose something strictly less than 1/2. I don't want more than 1/2. And I want something small enough that I can work with. So I normally will choose things like 3, 5, and 7 as a starting point. Those are usually good numbers. And then you work your way up or down. I'd love to get 3. Yeah.
You mean less than 1/2 of the items?
Yeah, less than 1/2 of the items. You don't want anything more than that. So I would never go above 13 in this case, or above 11, I should say. Does it have to be odd or even? No, I prefer odd numbers for something that I'll explain in a couple weeks when we get to it. It's much easier. Okay, so let's run it in R. Watch the time, we got 10 minutes. So here I'm running, I'm going to jump down to 24. I'm not going to do 21 yet. We're going to do that in reverse. So here is my factors. Notice I added another parameter here called rotation equals none. If you do not specify a rotation, it defaults to none. So I'm going to run this line 24, and nothing happened. It just sat. Well, the reason it sits is because I've got to print out the results of this fact analysis, and I need this cutoff. I'm going to explain what that is in 1 second. Let me move this up. We're going to run this. Now I get all sorts of numbers, right? Fact now I get uniquenesses. Oh, that's going to be interesting. And look what I got second. I got my loadings, which is nice. Oh, and look at this. I got SS loadings. You know what this SS loadings looks like? What does this SS loadings look like? But you know what the SS loadings look like?
PCA.
From PCA. What specifically was there? Keep going. Give me a hint. It begins with the letter E. It rhymes with eigenvalues, or eigenvalues if it's more Irish, I guess. Is that right? It's just, I took a guess. I took a shot. I was like, I think it's right. All right. So I run this, and now I have my loadings. I have this p-value, which we're going to ignore, and I go back to my PowerPoint. Here's what this means. So the output of the factor_now function provides the uniqueness values first. If my factor solution was good, what would I hope for? All of these to be what? High or low? High or low? Low. I want my uniqueness function to be low. Now, if I look at them, A1, that sucks. I got 0.6 on some of the other ones. Not sure that's great. Some of them are okay. I love the ones on N. That seemed to go well, except for N5 and so forth. Everybody see that? A little arbitrary, but no. This is going to be extremely arbitrary until you get to your loadings. Right now, if it's over 0.75, it's a problem. Okay? I can guarantee you anything 0.75, 0.80, only 20% of the variance is being explained by the factors. That's probably not good. That's probably going to be an issue. Okay? Now, these items return the loadings. Now, if we look at this, in this case, I've got a whole bunch of different loadings here. I got 0.195, 0.143, etc. But if you look in your R, I don't see any of those numbers. The reason you don't see any of those numbers is because my cutoff was set at 0.4. So if I change my cutoff, say, to 0.1 and run it, now I got a whole bunch of numbers, right? Now, this is what's great about this function is we said we wanted loadings that were a little bit higher. Good cutoffs are around 0.4. They can go a little bit lower, like 0.37, 0.35. Lower than that, and it's going to be a little bit of an issue. But that's also dependent on the number of items you have. So I'm going to change this cutoff back to 0.4. When we look at it, I still have a problem. My problem is that I have overlapping loadings. Everything seems to load on factor 1, and some of them overlap with factor 2. Some of the C's are a little bit different over here, but I don't have anything clear, right? There's nothing that's clear here. So this doesn't really help us. Not that much, at least. So now what we'll do is we'll do a rotation. Generally, orthogonal rotation is easier to interpret according to some folks. However, not everyone agrees. Some people say that oblique rotations are better because they're a richer way of interpreting the data. Orthogonal rotations may lose some information if there exists correlation between the two, because I've got to split them apart. If two factors were correlated and I'm forcing them to split, I'm going to lose a little bit of information. Remember with the loadings that I showed you, Varimax and then Promax, where the Varimax was much lower, like 80%, and the Promax, the ortho oblique on the PowerPoint was like 0.99, right? That's some information loss. Not material, but it's only between the separation of the two. If you believe your factors are not correlated, the orthogonal rotations will produce the same as the oblique ones. So in other words, if there is no real correlation between the factors, not between the items, but between the factors, that means basically the orthogonal will produce the exact same result as your oblique. Okay? So now what we're going to do is I'm going to do a Varimax rotation, and this is the result. If I look at this, I've got some nice clean items in the factors, don't I? All I did was change the rotation. So what I'm going to do is go back in here. I'm going to run this next line on 28 and 29, and I'm going to now look at my rotation results here. Look at all of those. If you look at those, it is clear that factor 1 represents what? The N items. Factor 2 represents the E items. Factor 3 represents the C items. Factor 4 represents the A items except what? A1. Something's wrong with A1. Factor 5 represents all the items except O4. You asked about the negative numbers on the loadings? It's right there. And it could just be the way the question was asked. Think about this. You have a question that says, I like the product that I bought. And another one says, I do not like the product that I left, or something like that. Could be the same principle about a product, but it's in opposite directions just because of the wording. Okay? Perfectly fine. So if I look now at my cumulative variance and my loadings, oh, look at this. 2, 2, 2, 1, 1. They're all above 1 as an eigenvalue criteria, so I can use that. But look at the factor variance explained, 42%. Is that a lot of variance explained? It's not. So what I might want to do is what? Maybe I want to increase it to 6. Right? Under the Varimax, I just did Varimax. So I might want to do 6. Look at that. I added the 6th factor, but look at my eigenvalue number. It's way below 1. Right? How much more variance did it explain? Not much. So it didn't really add much to it. So that doesn't really help. That 6th factor doesn't help. So the 5th factor, honestly, is pretty much what I'm going with. But now what I'm going to do is I'm going to rotate it using the Promax, because I want to see if there's any relationship between the factors. When I run the Promax, here's what happens. My factors pretty much remain the same. I do lose N4. That's weird. Something happened with N4. Something's gone with O4, and A1 is still gone. If you look at the uniqueness, A1 is at 0.843. N4, who did I lose? I lose N4 and 5. N4 and O4. So O4 was at 0.75. N4, weirdly enough, was here at 0.5. Not sure why I lost that one. So that might be interesting to look at and see what's going on. But when you run Promax, look what you get. You get a set of factor correlations. And I read this the way I read normal correlations. Hopefully, I've got something, and I do. I've got factor 3 related to factor 1, 0.376. A weak to moderate correlation. You agree with that? At 0.37? It's not great, but it's something there. So factor 1 and factor 3. Well, what was factor 1 and factor 3? Factor 1 was neuroticism. Factor 3 was conscientiousness. That's interesting that they're related to each other. It's very interesting that they're related to each other. But guess what? Now I can do something with it. Now I have a connection between neuroticism and, I think it's conscientiousness. Yeah. So we ran through all of those. Yeah, conscientiousness. I can also see that there's something with factor 1 and factor 2, neuroticism and extroversion, right? Because the correlations told me. Does that make sense? Okay, we're going to pause right here. If you have any questions, anybody have any quick questions? I'm going to stick around for a while, so. Yeah.
In the previous slides, there was a beta right before the
Yeah. Way back here?
Yeah, there's a beta before the factor.
Yeah.
Where do you get the beta?
It's probably the loading. I'll have to find it. We'll take a look and we'll find it.
It's the something equals.
Oh, that's way at the beginning. Yeah. You mean here?
Plus.
This.
Yes.
It really was just a B. I did that to relate it to regression. It's not really a beta. It's a loading. It's actually now. Yeah. Oh, yeah. So look, the homework is open. There is no, it's due today, but I'm not taking off any points. Get it in over the weekend, get it in by next week, and you're fine. Just don't wait too long because the next one comes right after it. It's on. Okay? All right.
Sports data.
Take care, Anthea.